we're going to solve a problem like the one we did in class today on 1509. It's pretty much the same one that we did, where there's friction with an object on a slope. So start with a little sketch of the object on a slope, where that's the angle and the object is pretty simply a box. Now when it comes to an object sliding down a surface, or an object moving in any direction in any way at all, the only reason why something is going to move is due to the forces on it. Now in this case, this object is really only going to move along this direction. It's not going to go up or down at all, because it's not going to spontaneously fly into the air and it's not going to fall into the surface. So only the forces in that direction are the ones that are going to be responsible for its motion. So if we put some forces on here, we've got the normal force, we've got the weight straight down, and we've got friction parallel to and up the hill. And when you put something on a surface, if you just place it there and leave it at rest, well, maybe it'll slide, maybe it won't. In order to figure that out, we have to compare the force that's trying to pull it down the hill to the friction force. If the friction force is greater or great enough, then it's going to stay put, like you standing on any old hill. But if the force drawing you down the hill is great enough, and because the angle of the hill is steep enough or the coefficient of friction is small enough, then you're going to start to slide down the hill like you were on a sled. So in order to determine what the force is pulling it down the slope, we need to reorient our coordinate system. Now typically we've dealt with a coordinate system that was in this direction. This is the x and this is the y. But since all of the motion is going to incur in this general direction, we can reorient our coordinate system so that it makes our life easier when it comes to the solution. We don't want to have acceleration in both the x and y directions, because that means we would have to solve for acceleration in both the x and y directions. So let's not do that. Let's reorient our coordinate system so that the x direction is parallel to the slope and the y direction is perpendicular to the slope. So now we need to start considering what forces are in the x and what forces are in the y. The normal force is very clearly in the y direction, it's perpendicular to the slope. Friction force is in the x direction, it's parallel to the slope, and weight is sort of in both. So that's the one we need to find the components of. As we talked about today, when we want to find the components of the weight, we need to break it into its x and y components. Its y component, Wy, is going to be there, and its x component, Wx, is going to be there. But this triangle right here, I'm going to draw that a little bit larger. Wy, Wx. And this is the full W. This angle right here, as we talked about, is also the same as that angle right there. So knowing that angle, we can work through and figure out that if this is the hypotenuse, then this is the adjacent side to that hypotenuse. So Wy is going to be equal to W times the cosine of theta, and Wx, since it is the opposite side from where that angle is going to be W times the sine of theta. So I'm going to redraw this diagram only with these x and y forces and not with that weight force. Normal, friction, W in the x, W in the y. Now in problems like this, where you've got friction, you can pretty much be sure that you're going to have to deal with both the x and the y directions. Today, I think in class, we dealt with the x direction first, but in this video I'm going to do the y direction first, because knowing ahead of time that we're going to have to do both directions, I'm going to start with the one that's a little bit easier. That's the y direction, because I know ahead of time that if the acceleration is in the x direction, well then I know that in the y direction there is no acceleration and the sum of the forces equals 0. So I'm going to start where the sum of the forces equals 0.